Photoelectric effect is a cool little experiment. Confirms Planck's work, confirms the particle model of light. We will loop back and talk about the wave model again later, but for now we'll just flow ahead with what the photoelectric effect shows. Basically, Planck said that if we know the wavelength, that's enough to tell us the energy of the light. Planck's equation was E equals hf, but from our universal wave equation, we know V equals f lambda. If we're talking about light, the V is the speed of light, we call that c. Or we can say F is c over lambda. So Planck's equation, E equals hf, is the same as E equals hc over lambda. What that means is that each bullet of light, each little photon of light, has a particular amount of energy. We can calculate it by crunching out the equation. The h is Planck's constant. It's this crazy small number, 6.626 times 10 to the negative 4. The speed of light is 3 times 10 to the 8. And this wavelength, 630 nanometers, that's 6.3 times 10 to the negative 7. That's a common value if you're using like a red laser pointer. If we crank all that out, my calculator, I'm getting an energy of roughly, I'll go 2 decimal places, 3.15 times 10 to the negative 19 joules. That's how much energy each little photon of this red laser pointer are delivering. The question I made up says the work function of the metal is 2.3 in this funny units of electron volts. The conversion to get out of electron volts is to multiply by 1.6 times 10 to the negative 19. When we multiply that out, it works out that the work function of this particular metal that I made up is roughly 3.68. So the outcome of this is each little machine gun bullet of red light has an energy of the 3.15 number, but the work function of the metal is 3.68. Therefore, no electrons will be ejected. The light doesn't have enough energy to beat the work function. This would be like going into a store with only $3.15 and trying to buy something that costs $3.68. You don't have enough, in this case, not enough energy, no electrons will be ejected.